Greetings. I hope this message finds you well. I have disturbing news. The dark side is close. The only answer is more science. Everybody, welcome to another exciting Earth Day. Things are a little different this year because we can't get to school, but that doesn't mean we can't investigate some of the interesting environmental experiments on how the Earth is changing as a result of human impact. This year, I thought we'd talk a little bit about plastics and plastics in the ocean and how the warming of the oceans is really going to affect us. What do you think?
Yes.
Sound good? Okay, let's go. When we first began our walk, there were no signs of life anywhere. Look at this park. It's wrapped right up. But then we started to notice, through the cracks of sidewalks and in people's gardens, life everywhere. It is spring, after all. This is when all things renew. Then suddenly, as we got deeper into the forest, we realized, look at all this garbage. It's everywhere. Hi, we're on a quest to find out where all of this waste goes once the summer hits. Now that the winter's gone, all the snow's disappeared, we're left with this barren garbage just everywhere. What happens to it? That's what we're trying to figure out today. Hey, what about me? Down here. Hey, over here, down here.
Hey, who said that?
I said it. It's me, down here. You gotta get me out of here. It's so stinky. It stinks everywhere. You gotta take me with you. I can help. Please, just get me out of here.
We'll rescue you.
Wow, I really thank you for saving me. Man, I've been there all winter, and it stunk, and it was wet, and cold, and boring. The only person I got to talk to was a bottle of Aquafina, and she just kept telling me how fresh she was. No, not the actress. The bottle, the water? Yeah, boring. I can't believe it. First thing, I'm just sitting in a container, about to get filled up with a delicious smoothie. Next thing you know, I'm being tossed right over the bike, into the bushes. Who would do such a thing? I can't believe it. But listen, I'm here. I want to help. I know so much about plastic. Wow. Oh, wow. You're learning about plastic? I know so much. Come on, bring me with you. I can help for sure. I can help. Wow, that was really fun. We got to see so many interesting signs of spring, but we also, on the other hand, saw lots of pollution. But we did meet a new friend, Mr. McCup. Mr. McCup, do you think you can help us solve this problem of ocean warming and plastics in the ocean? Oh boy, plastic in the ocean is a real problem. Imagine, you're a sea turtle and you're swimming around through the water looking for a nice meal, a nice jellyfish. And there you see one. You go up, you sneak up on it, even though jellyfish can't see, and take a delicious bite. Yum. Ooh, you spit it out. Why? It's plastic. This is not good. Not only that, if the turtle eats it, it can become very sick, might even die. The problem with plastic is that most of it is single-use plastic, things like straws and plates and knives and forks, and they get thrown out. 40% of all the plastic in the ocean is this single-use plastic trash. Scientists think about 8.8 million tons of plastic wind up in the ocean every year. That's as if you stacked up 5 plastic grocery bags full of trash on top of each other on every foot of the coastline in the entire world. How does it all get there, though? Plastic left on the ground as litter often blows into creeks, rivers, and eventually ends up in the ocean. And because the plastic trash is different from other types of waste, it doesn't decompose back into nature like an apple core or a piece of paper. It stays in the ocean forever. Can you believe it? And don't get me started on the warming of the ocean. Do you know that the ocean covers about 70% of the Earth's surface? The ocean plays a large part in the Earth's environment. Its biggest role is to soak up energy in the form of heat
and distribute it more evenly throughout the Earth. The ocean also helps absorb carbon dioxide. Hey, maybe you can show these kids an experiment on how carbon dioxide can be compacted in different forms like oil and gas.
That's a great idea, Mr. McCup. Let's first figure out how it is that the oceans are really warming. It turns out you can do this experiment at home. All you need is a Ziploc bag, some water in a cup, preferably plastic so you can pour it inside the Ziploc bag, and some Alka-Seltzer. You can get Alka-Seltzer online, or most pharmacies have it. What we're going to do to represent this is we're actually going to fill a little bit of this Ziploc bag with water. And this is going to represent the ocean. Now, the oceans vary in temperature depending on where you are on Earth, but for our purposes, what we're trying to do is see how these oceans get warmer. And it turns out it's about heat transfer. So carbon dioxide is one of the main culprits of global warming. As we burn fossil fuels, the carbon dioxide goes up into the air, but it also gets absorbed inside the water in the ocean. And that results in changing amounts of carbon dioxide in the ocean, which makes it acidic. But this also shows you how much carbon dioxide is produced by simply a chemical reaction as simple as Alka-Seltzer. If you can imagine it being like oil or gas, that could be really different because there's going to be so much more carbon dioxide produced. So what we're going to do is you're going to take your Ziploc bag and you're going to hold it open carefully. Try not to drop it. And I'm going to pour some water in it. Not too much, just enough. Keep it there, that's perfect. And then I'm going to hold it open, all the way open. There you go. Let it spill. Okay, good. I need some for mine as well. So what we do is, you put it, depending on the size of the Ziploc bag, because you're going to be producing carbon dioxide, you don't want to fill it up too much because the bag may pop open when you don't need it. So what's cool about water is it fills its container, right? It's a liquid, and so you can keep it kind of down and open. And what you're going to do is you're going to take your Alka-Seltzer, and you're going to open it up, and you're going to take one of the pills. And don't drop it in yet. Wait till I say, because what you have to do is you have to be really quick. Because as you drop it in, it's going to start the process of producing some carbon dioxide bubbles. And you'll see the bubbles happen. And this is the same effect as us burning fossil fuels. So when you take an Alka-Seltzer, imagine it has been extracted from the bottom of a mine or dug up in the ocean in an oil well, and this is what you get. Now, of course, oil is liquid, but it still serves the same purpose because we use the oil to produce chemical reactions, produce heat and energy for us. This is going to do the same thing, and the byproducts are very similar. Carbon dioxide, carbon monoxide, in the case of burning fossil fuels, but the result is increases in amount of carbon dioxide. So this simple experiment really shows us how much energy is inside this tiny little piece of Alka-Seltzer. Imagine liters and hundreds of liters and thousands of liters of oil, how much energy is stored in there. And the byproduct, of course, is the increased carbon dioxide. But as you know, it's hard to get anywhere these days without gas, unless you have an electric car. Okay, so everyone's got their Alka-Seltzer. So on the count of 3, we're going to drop it in, and then you're going to close the bag as best you can, and I can certainly help. And then we're going to observe, because that's what good scientists do. Are you ready? 1, 2, 3. So you close it back up, and you have to be very quick, because you want it completely sealed. You want to wait for that little snap. We'll wait there, and we'll do it here. Hear those little snaps. And if you hold it up now that it's safe, you're going to see all of this gas being produced. Well, this is a reaction. There's carbon dioxide being produced here. And as it goes up, you'll notice the pill is disappearing because it's a chemical reaction that's actually changing into gas. It's going from a solid to a gas because the water is causing it to do that. So if somebody has indigestion, they would take it and it would react with their stomach acid to produce this. And for our purpose, you can see that as it disappears, it also is producing a gas. Now, if you're very careful and you have a smaller Ziploc bag, what you'll see is the bag will start to inflate. And that's simply the gas. The gas is changing it. So if we were to weigh this, it would weigh the exact amount of the Ziploc bag plus the water plus the Alka-Seltzer, even though the Alka-Seltzer's gone because it's been changed into a gas. Now, what does that mean? Well, it means a lot of things. Number one is carbon dioxide is hard to see. So because it's like oxygen, an invisible gas, we don't really know how much is in the atmosphere unless we measure it. Can't just look at it and tell. And so what it does is it goes up and it goes into the atmosphere. And now you can even see the little bubbles in there. It's still happening. It goes into the atmosphere and it stays there. And it's a heavy gas, so it kind of sits low. And what it does is it causes the heat from the oceans and the earth to get trapped inside the earth, increasing the temperature of the ocean, of the land, and the entire earth as a whole. And so this is a cool little experiment you can do. You can mess around with the size of the Ziploc bag. If you have a smaller one, that's okay. You can add more water to see if you have a different result. You can put multiple Alka-Seltzers in one to see what happens, because you're going to produce even more carbon dioxide. And each of those are variables, we say in science, that changes the outcome of the experiment. And it shows us if we continue to add Alka-Seltzer to these pill after pill after pill, eventually this Ziploc bag will have to burst its seams because the carbon dioxide gas wants to fill all the space, and if it runs out of space, it'll just exert pressure on the sides of the Ziploc bag. So that's a really easy experiment that you can do at home, and I invite you to try it. Let's move on to something a little bit different. Let's figure out what happens when the ocean does get a little bit warm. Let's get a little bit warmer. For that, you're going to need some things. You're going to need preferably a clear bowl. It can be plastic. We have glass ones. You need 3 of them. And I'm going to get the third one here in a second to show you. So you're going to fill them both up with just tap water. I use the coolest as possible. And then you're going to have one with parents' help or using the tap, try and get it as hot as possible. So we'll be back in a second to show you what you're going to do. Okay, Mr. McCup, can you help us figure out a way to use hot, medium, and cold water to determine its effects on the environment?
Oh, it's really easy to see how a warm ocean can have a detrimental effect on the entire climate. Do you know that fish and other animals in the ocean breathe oxygen, right? And they give off carbon dioxide, just like we do. Then the ocean plants take in the carbon dioxide and give us oxygen so that we can breathe it. The problem is, a lot of the carbon dioxide being produced by humans is getting soaked up in the oceans. This is causing acidification and can lead to a difficult way for the ocean to lose its heat. One way the ocean affects the climate in places like Europe is by carrying heat up to the north, in and around the Atlantic Ocean. Way up in the north, cold water in the Atlantic Ocean sinks very deep and spreads it all around the world. The sinking water is replaced by warm water to the surface and moves to the north. Scientists call this the Great Ocean Conveyor Belt. The heat is carried north, helps keep the Atlantic Ocean warmer in the wintertime, which warms the nearby countries as well. We've all seen that warm water in the Caribbean, right? Beautiful. Now, how are you going to see that the warm water can have a bad effect? Well, that's easy. Just show differences in temperature and how it affects cold areas like North and South Poles, where there's glaciers and icebergs. Do that, yeah.
Well, that's a great idea, and we can even do this experiment at home. So like I said, if you have 3 clear containers, we're using glass. Be careful if you're obviously using glass, but plastic will work too. Ideally, you just want to see through it. And if you don't, you can still do it because it's not going to ruin the experiment by any stretch of the imagination. So what we've done is we've taken water to cool it down as much as possible. We could use ice cubes. I just grabbed an ice pack from the freezer, and I'm putting it in there to try and cool this water off. The medium one, the water's been sitting here for about 5 or 10 minutes, and this big one is going to represent our hot one. And I've boiled water, but you don't need to boil water. And I don't recommend that if you're young, you do that without an adult with you, because it can be extremely dangerous. So I'm just going to use the bigger one because the water's so hot to protect it a little bit. So as I put the water in, you can see that it's steaming up and changing to a gas. Now this is going to exaggerate the effects of oceans getting warmer, but that's kind of the point. We want to see, just like we did in the other experiment, different kind of models on how much is going to change if the oceans get really warm. So you want to start with the hottest you can get. So with boiling water is about as hot as you can get. So what we're going to do now is we're going to take a piece of foil. So you need to have a foil. And all you're going to do is you're going to make a boat. So you can make a boat really easy. You just kind of fold the sides in. And kind of make it like a square like this. And then you just kind of want to tip up the sides so that you can get it to float so that the water doesn't come in. And it doesn't have to be beautiful. Again, it's not art class, it's a science experiment class. So there we go. We've got our little boat. It doesn't look like mine's not going to take on much water. Pretty simple design. You can even just kind of bend it. It doesn't really matter. So what we're going to do now is we're actually going to take some butter. Butter or margarine works really well. And we're going to take this butter and we're going to cut it into 3 pieces. 3 equal pieces, ideally. And what we're going to do is we're going to put these pieces in the middle of our boat. So this is going to be our barometer. Now, do you guys know what happens when butter gets hot? What happens to it?
It melts.
It melts, right?
It melts.
And what happens if butter gets really cold? Does it melt?
No.
It stays a solid. So how fast this butter is melting is going to tell us what it means if the oceans get hotter, 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 hotter. So hopefully we can take a guess, and that guess will come true. So what do you think is going to happen when we put the boat in the cold water? Do you think the butter's going to melt?
It's going to turn like a little soggy, but it's not going to melt.
It's not going to melt. Okay. What about the normal temperature water? Just room temperature.
It's going to be fine.
It's going to stay the same. And what happens with the hot water?
It's going to melt.
It's going to melt. Fast, slow? What do you think?
Fast, slow.
Slow? Okay. Let's check it out. So what we're going to do is we're going to put in the middle of our boat a piece of butter. Let me just make sure your sides are all up here so it's not taking on water. Good. And put it here. So I'm going to take the ice pack out of this water. Wow, it's cooled down a lot. We've got the ice pack underneath to keep it cool, but we want our boats to float. So we're actually going to gently put our boat on top of the water so it floats. Just like that. Perfect. And you do yours. Hurry. Melting. Oh no. Okay, so we're going to get a close-up of this. We'll be right back. This is the hot water. What is happening?
Melting.
Look at that. The room temperature water?
Not
so
really.
much. And of course the cold water. So we can see between the differences in temperatures how fast that can melt. So to us, we don't often go to boiling ocean, but we do go to warm oceans, and that water can travel up through currents. And if you imagine that the butter is a glacier full of fresh water or an iceberg, and it encounters the warm water, what's going to happen? What do you think is going to happen? A big iceberg goes into warmer water. What happens to it?
The water's gonna turn cold.
The water will turn cold, and what happened to the iceberg? Does it just keep going?
Mm-hmm.
I think the iceberg's gonna melt myself because the water's warm. Just look at that butter; it's melting away, and it's going to change the ocean level. It's going to make the oceans a little higher. And what does that mean? Well, that means that we're gonna flood some low-lying areas, and it also means that the ocean currents are going to cool down, which can have a dramatic effect on the weather. Okay, so now you see how this effect is. And if we're going to leave this here for the next 10 or 15 minutes, and we'll come back and see. I can already tell the hot water has just completely melted the butter. And that's understandable because it is very hot. But it's interesting to know that even the room temperature butter is actually still very solid, as well as the cool water. So we'll just leave them for a little bit, and then we'll come back. Next up, we have to think about other uses of plastics. Because when we were on our walk today, we saw so much plastic being thrown away. And as you heard Mr. McCup say, somebody was just drinking him and tossed him into the forest. Where does all this plastic end up, Mr. McCup?
Like I mentioned before, 8.8 million tons of plastic wind up in the ocean every year. That is a large amount. How does it get there, though? Well, most of it gets blown there through the wind, people littering, and it eventually travels from these rivers down towards the ocean. And because plastic trash is different from other types of waste, it doesn't decompose back into nature like an apple core or a piece of paper. It stays in the ocean forever. That means discarded fishing nets and six-pack rings can entangle animals. Harmful straws and grocery bags can be mistaken as food.
That's right. It ends up in the oceans. 90% of all littered plastic ends up in the ocean. And it gets caught up in the currents and gets stuck rotating around. And over time, the plastic breaks down into tiny little microscopic pieces that nobody can see, not even fish. And they inadvertently breathe it in because they need to use their gills to breathe. And it can actually hurt them really bad. Also, it affects the growth of plants in the ocean, like algae, because the plastic is actually taking up space, even though it's invisible. So we're going to try a little experiment today to see what alternatives there are to using plastic. We've seen paper, of course, because now there's paper straws. But what about natural plastic? Is that even possible? What do you think? Well, it certainly is. You can make a nice, easy natural plastic with a few simple ingredients. Okay, let's make some natural plastic. Really easy to do. This one you're going to need an adult's help because you're going to have to heat the substances up in order to produce the plastic. So what do you need? You need a pot because you're going to be pouring ingredients into it. And this pot's going to go on the stove, so it has to be a stove pot. You're going to need some vinegar because the vinegar is going to cause a reaction. It's an acid, acetic acid. You're going to need a sieve, and the main ingredient is milk. That's right, milk. Did you know you can make plastic out of milk? Yeah, a long time ago, in the early 1800s, they used to use milk all the time to make buttons for shirts. And it's a nice, easy way to do it. Let's see here. How are we going to do this? Well, we're going to take some milk, and we're going to pour it into the pot. Now, how much milk depends on how much plastic you want to produce. So we'll fill it maybe a quarter of the way or less full, maybe a cup, 2 cups, 3 cups, 4 cups. You're going to have to play around with it to get the right consistency. And then we're going to go heat this up. So we'll move over to the stove now. And okay, so what we're doing is we've put the pot of milk on the stove and we're heating it up. It's not on full blast, it's about halfway. I've got my vinegar ready, and you're going to need a spoon as well. And the spoon will be to add vinegar to the milk. And what you want to do is you just, once it starts to simmer a little bit, you want to keep stirring and make sure that it's nice and consistent. Because once the vinegar gets added, you're going to see an awesome reaction. We've got our milk steaming away here. And now what we're going to do is we're going to carefully add the vinegar to it. We're going to carefully add the vinegar to it. And we're going to continue to stir. So again, it's 1 spoonful is the standard, but depending on how much milk you've used, you may need to add more, and you'll see what happens. So there we go. We've added it. We're going to continue to stir here. And I can smell it. It smells vinegary. But if you look closely, I'll just turn it down here because we're getting an effect. It is now starting to break apart. Now starting to break apart. And Mr. McCup is going to explain to us later why this is happening. In the meantime, we'll focus on getting it done. So I'm going to add a little bit more because I think I had probably too much milk. Not very much in here. We don't want to overdo it. That's better. And okay. So what the next step is to carefully filter it into some cooler water so it coagulates. So we'll be right back so you can show you the filter. Okay, we've got a nice coagulated milk separated here. And this is actually called casein. And what we're going to do is add this sieve to this bowl. Now, to make it a little easier, we've just got some water. We're going to add some water in there. And what it's just going to do is just cool it down really quick. And that'll help it kind of clog together. So my fearless assistant is going to hold the sieve. Nope, you want to hold it on top. There you go. And we're going to sieve through it and see what's left. There we go. Okay. And I don't want to get too, it's a little full here, so I'm just going to empty the water. My fault to put too much water in. Okay. And we're going to keep going. Bam. And isn't that nice? All right. So let it go through. Okay. Good. And I'm going to dump this. And add some more cold water to it. There we go. Now, I'm going to dump it in. And you're going to see it cool off really quick. There we go. Get it all in there. It's pretty warm, actually. It's just, all this is doing is just cooling it off. Okay? The rest can go on our plate. Perfect. Put this back here. Now, assistants, you are going to get a little bit mucky. So make sure your sleeves are rolled up. Make sure this is good. We're going to grab some handful and we're gonna squeeze the water out and pop it onto the plate. And what you have is a little bit. Go ahead, grab your own. Just grab a handful of it. And it's clumpy to start, but when you work it around and you push it down, you actually can make it. You want to try some? Grab a handful out of here. Just make sure you squeeze it before you go to get rid of that extra water. It just takes a little bit longer. And you've got these little proteins left that we're using here to produce a little bit of plastic. So it's a little crumbly right now, but if you kind of work it in your hand for a while and squeeze out that water, it will bond together enough that you can do something with it. So what I'm going to do is I just kind of squeeze mine in, and I'm going to make like a button here. I'm going to flatten it out and make a little tiny round button, just like they did in the old days. There you go. Just make sure to squeeze it out because all that water just slows the process down. So grab it with your hand, Henry, and squeeze that water, and then you'll get much better, much more effective ones. So it's better if you use higher fat content of milk. It'll produce a little bit more, a little stronger natural plastic. But when this settles, we'll come back and you'll see that this is actually a double for a fairly strong plastic. Okay. Okay, so we're just waiting for our milk plastic to dry a little, but we want to know what is happening here. So I think Mr. McCup should be able to explain it really well. What do you think?
Oh, I know this one. Plastics are a group of materials that may look or feel different, but all can be molded into varied shapes. The similarities and differences between different plastic products come down to the molecules that comprise them. All plastics are comprised of molecules that repeat themselves in a chain called a polymer. Polymers can be chains of either one type of molecule or different ones, which are linked together in a regular pattern, just kind of like a Lego blocks if you all put them in a chain. Also, in a polymer, a single repeat of the pattern of molecules is called a monomer, which can consist of just one type of molecule or include several different kinds. Well, milk contains many molecules of a protein called casein. Each casein molecule is a monomer, and a chain of casein monomers is a polymer. The polymer can be scooped up and molded, which is why plastic made from milk is called casein plastic. Wow!
Okay, well, that's it. Those are 3 easy experiments that you can do at home with some materials that you can easily find. We hope you learned a little bit about Earth Day today and hope you enjoyed the experiments. And before we go, I just want to thank my assistants, Charlotte and Henry, and of course Mr. McCup, who's taught us so much about the Earth today. The problem is, what do we do with Mr. McCup now?
Well, I think we've learned a lot today, and it's my time to go. Now I've got all these cracks in my side. I don't think I'd be very useful as a cup anymore. I think the best place for me is the recycling bin.
That's a great idea, but are you sure?
Yeah, no worries. That's the best thing about being a piece of plastic. You get to be recycled, and you get to be reincarnated into something totally new. I can only imagine what I'll come back as next. Maybe I'll come back as, I don't know, a new car? Maybe a car part? Maybe part of a spaceship? Wow, I can't imagine. Yeah, just put me in the recycling bin.
All right, everybody, thanks for watching.
Oh, yeah, this feels great. Thanks for everything. I'll see you again soon. Bye. Oh, I feel brand new. Oh, wait, what am I? An Aquafina bottle? No!